Hi everybody, and welcome back from the morning tea. This is one of the two parallel sessions. If you're here to listen to data, AI and predictive intelligence, you are in the right room. If that's not what you want to hear, then you'll be next door. I'm going to get going. Now, we've had a little change in the program in that our last speaker of the morning has not materialized. So we're going to turn that into a Q&A session, where we will get an opportunity to ask some of the questions that are coming through on the Slido. So at the end, all the speakers will come up here and we'll have an opportunity to go through the Slido questions. Our first speaker this morning is Adam Stewart from Auckland Transport. Welcome, Adam.
Tēnā koutou katoa, no kotirana o kutupuna, I whānau mai o ki Kanata, kei tamaki makauro, toku kainga noho, ko Adam Stewart toko ingoa. Good morning, everyone. Atamarie, thank you for joining me on a beautiful day to hear me talk about freight. I very much appreciate it. What I'm going to be running you guys through is some of Auckland Transport's work and the data-driven freight planning that we've been doing, because despite what you might hear in RNZ, we are in fact doing quite a lot of work to help the movement of freight, and I'm going to show you some of the stuff that we're doing. Just to go over just some details on myself, to address the obvious, I'm not from here, you probably might have noticed. I'm from Toronto, Canada, and I arrived here in about 2023. Before that, I had about a decade working in transport planning in Canada in the private sector with dabbles in the United Kingdom and United States. And my background is in geography and GIS mapping, which kind of has given me that high-level network perspective that I think really helps me in transport planning. So the things I'm going to cover today are, one, why do we need freight planning? It's generally not the sexiest of transport planning modes, but very, very important, which I'll get into. I'm going to touch on AT's transport network plan, which you might have heard of before. I know my colleague Shalali has presented on Future Connect in the past. Going over the work that we did to incorporate data and review the strategic freight network, as well as touching on the end of how do we use freight data and what's happening next. So the team that I'm a part of, I'm a senior transport planner with the integrated network planning team at Auckland Transport. I'm the freight subject matter expert there. And I work with other modal subject matter experts for cycling, public transport, walking, general traffic, all that sort of thing. Now, AT obviously has individual modal project teams that help operationalize and come up with the sort of infrastructure that goes in. But our job at INP is to take all of that and form it into a cohesive network, make sure that everything's working together, and manage any conflicts that might arise, which is very, very important. And particularly is important when it comes to freight, because freight and some other modes such as cycling, when things happen there, it's particularly serious. So again, why do we need freight planning? As I mentioned already, we really need to balance the safety of the road users with the movement of freight. We move a lot of freight in Auckland. It is the center of most freight movement in New Zealand, and it's only projected to go up. So it's something that's already important. It's going to become even more so in the future. 95% of freight moved in Auckland is using the road network, which is a lot. Movement of goods is really necessary for a city to function, and it's what drives a city's economy. And if goods are caught up in congestion, you're going to have a city that starts to decline. We need to be able to move goods. And there's limited road space to move around. That's the case in Auckland, it's the case in many other New Zealand cities, and it's something that we have to balance. And one of the things that AT does, obviously, is the movement of people. That's really important. That's what we do on our bus network, what we do on our trains. But it's not the only important thing in a city. We need to be able to move goods as well. And as I mentioned before, when it comes with freight, any collisions that happen, especially with vulnerable road users, have a higher level of severity than other modes. So the things that we deal with, although our primary Responsibility at AT is freight on roads. As I said, that's 95% of all freight moved in Auckland. We also deal very closely with KiwiRail as far as freight on trains, and with the Port of Auckland for freight on ships. And one thing actually not on this slide, but I realize is that we also work with the Auckland International Airport because there is freight that comes in on cargo planes as well. So how do we keep track of everything? How do we manage these competing networks that all use the same space and all have their own priorities while keeping everything moving and everyone safe? Future Connect is the answer to that question. It's AT's transport network plan, and what it does is it brings every mode all together. It identifies issues and opportunities, and it helps kind of inform the investment decisions that Auckland Transport makes. Future Connect was first published in 2021, and it's undergone updates in 2023 and 2025. That 2025 update is what I'm primarily going to be speaking about today. And it includes both the existing and first decade network, and all updates to it go through multiple iterations of modal SME inputs and then review processes for discussion. This is a snippet of the Future Connect online platform. It is publicly available, and it's a great resource. It includes all the different modes in one spot. So you can see the public transport network, you can see the cycle and micromobility network, the walking network, freight, and general traffic as well. Freight is considered alongside all the other transport modes and not in isolation, which is very, very important. So this is the strategic freight network. It was originally developed in 2009 with a lot of input from the freight industry. We did have our own data that we were using, but it was a lot of back and forth with the industry on what are the routes that they use, what are their preferred routes, what are the ones that can handle freight, and it's how it moves most efficiently through Auckland. It includes all the freight corridors that are on rail, the vehicle ferries, because freight moves to Aotea, Great Barrier Island, and Waiheke Island through those. It has the strategic freight network levels, 1A, 1B, which are the most important ones. I'll get on that a bit later, and 2 and 3, as well as access roads and the overweight and overdimension network. So I'm going to touch on the project we did with reviewing the freight network. And why did it need review? So Future Connect 3.0 was something that was completed in 2025. It was a full refresh of all modal networks, and that included freight. What we wanted to do was test whether the freight network that had already existed still was fit for purpose. We retrieved a lot of data so that we could check it with that, and we needed to refresh to inform the next RLTP cycle. We also wanted to move from a primarily industry-led decisions on the strategic freight network to more of a data-driven one, and I'll get to the results on how that worked out later. And we also wanted to identify any corridors that might need to be added or amended. So this is the overall approach. I'll go more of a deeper dive into what we did, but it had 4 main work streams. First, we had to stockade all this freight data. We had a lot kind of collected throughout AT, and we wanted to get it all in one spot so it would be very, very easy to assess and do our analysis there. So that included, obviously, the freight networks. That came from Future Connect. It included road classification, so ONRC. Multimodal networks, so this is the cycling and public transport network primarily. Land use context, so this is the Auckland Unitary Plan. Freight counts, we have other freight counts which I'll get to, but the NZTA and the AT traffic counts that we had done were used as a sort of sense check. E-road data, so that was our biggest purchase and what we really used to identify what were the busiest routes and if these routes were carrying as many trucks as we thought they would. And also committed projects. This is because we cover both the current network as well as the first decade, so that's up to 2034. So things like Penlink, which isn't in place right now, will be relevant to that first decade network. We then took all of that data and went through very, very specific network reviews where we looked at all of that contextual information, the major projects, as well as the freight demand on these corridors. But this process isn't one where we just take data, put it into an algorithm, and then that spits out the network, and that's what goes on the road. It does take some discussion, both with our other modal SMEs as well as the freight industry. We had multiple rounds of consultation with both the modal SMEs to try and figure out where some clashes between different modal priorities are and how we were going to get past that, and then obviously running things by the freight industry to say, these are the changes, or this is what our decisions were made. Does this make sense to you? Do you have any opinions? Take that back, review what we've done, and go from there. We then, of course, update both the networks, and I must emphasize that this all goes into different reports and plans that AT is publishing, the first being the Future Connect plan, which has just gone through AT board approval, and the Auckland Freight plan, which is currently in progress and will be published in 2026. So the first step in our review of the strategic freight network was first to make sure that our definitions and our hierarchy made sense. We did this, one, to simplify the language, and we wanted to make it consistent with the other modes. The other modes had their hierarchy, and freight was kind of at the time doing its own thing. We wanted to line it up more with what they were doing and help it seamlessly integrate into the system that was already going on there. For our hierarchy and our definitions, we have the primary network. Now these are the long distance, highest freight movements, most direct routes. Think your motorway, think your major arterials that are coming off the motorway. That's level 1A and 1B. Our secondary network, which is level 2 and 3, these are the ones that kind of connect to the primary network from these major freight hubs and other major destinations. That's level 2, 3. Our supporting network, these are local access roads, so think your cul-de-sac, your small local industrial road, which don't carry that many trucks in the grand scheme of things, but at the same time are extremely important for providing access to businesses. And they need to be designed around the movement of freight. And then finally, other networks you might notice on there have a tertiary level. Freight, we do not at the moment. That might be something that comes in the future, but not right now. So the step 2, this is where all of our analysis went in. So the first part of this in-depth analysis was reviewing the existing strategic freight network. Like we said, this was to make sure that things fit, they were still fit for purpose. And our first step with that was high-level GIS spatial analysis. The freight network's enormous, and it would be a huge task in order to provide analysis on absolutely everything, and not everything required detailed analysis. And so what actually saved us a lot of work was doing the spatial analysis to determine what routes already met all the criteria that we wanted, and then those were eliminated, and the rest could be brought down for more detailed analysis. For step 3, I'm going to include these because they were very similar processes. This is to identify the new strategic freight network corridors that we were going to add to the network, potentially. And so spatial analysis was done as well. We brought in our ERO data and our traffic data to determine what routes were carrying more than 500 trucks a day. That was the kind of threshold that we set at to bring in and do more detailed analysis. We then took both those existing SFN corridors and the new SFN corridors and brought it into a very detailed worksheet. I'm going to show that in a second. And finally, after that was all done, we brought to the modal SMEs, like I mentioned, to manage any conflicts, as well as the freight industry representatives to see what they thought there. So the thing to take away there is that every proposed change was tested against both data and operational experience. So in other words, what we're trying to figure out is, does it connect between the freight areas and other parts of the network? If yes, that decides if it's strategic or supporting. How strategic? Should it prioritize the movement of freight? That would make the difference between level 1, the primary network, and level 2 and 3 and access roads. What is the surrounding land use, and is the route shared with other modes and strategic priorities? If yes or no, that's what determines between level 1A and 1B and level 2 and 3. 1 just means it's a freight route. We only really need to care about freight. The other one means it's shared with the cycling network. It's in a residential area. That's stuff that we need to take into consideration. So obviously, completing all this data, and the whole point of us doing this review is to incorporate data into the decision making. Data is important. So eRoad was the primary source of data that we had purchased. We purchased it from RobinSite in 2025. They had aggregated the data and then provided it to us. It had come from freight operator telematics and required very strong privacy agreements. It consisted of over 700 million entries of vehicle movements in 23 and 24. So that is an enormous data set and something that our GIS team took a long time to process, and my gratitude absolutely goes out to them. And it represents a representative sample, about 40 to 50% of freight traffic, because it uses the ones that have that telematics provider. And so we provided an uplift factor at about 2.5 to that one, just to bring it up to kind of what the normal ADT would be for this route. Finally, don't worry about reading this. This is just to illustrate what our worksheet looked like. We had this worksheet set up and would do this for every single bit of corridor that we analyzed, whether it was existing strategic freight network or the potential new corridors. This is an example down in the Franklin local board. And we would put in all that data I mentioned before, plug it into this worksheet, and it would answer the questions: are the freight volumes appropriate for the network level that we had assigned? Is the road class appropriate? Does the land use align? Are there competing priorities? What should the corridor look like? And what is the safety outcomes result? And it would give us either, for the existing network, retain, remove, upgrade, or downgrade, or for the new corridors, add to the strategic freight network and what level, or do not add. And I must emphasize, this is a recommended outcome. We still know that freight planning takes a brain. This isn't an algorithm that we spat out. It would give us a recommendation, and we would look at it and be like, I don't know about that. Like, there's still some contextual information, and we would make the decisions based on that. So what next? We purchased this data. We did our review of the freight network. That was the end of 2025, and are we done? No. We still want to incorporate data into everyday freight planning. And so some of the future uses that we're doing, this is stuff that's in progress and coming in the very near future. We have origin destination data, that's stuff that's being processed, also gathered from eRoad. That helps us give insight into where is freight coming from in the city, where is it going. That will tie in as well to gate analysis, something we're also doing through RobinSite. And that will tell us what routes freight vehicles are taking. And so if we assign a particular gate, let's say State Highway 1 up in Albany, from there, if a truck goes through there, what route is it taking to get through Auckland? And that helps us identify where areas that we need to put more focus on, as well as adding insight into origin destination of both freight, and this would go into an interactive platform with other OD data at AT, like PT, cycling, general traffic, that sort of thing. Other uses of freight data that we're working on is dwell time. This is where we're going to look at hotspots throughout the city where freight is stopped at intersections, and it can tell us where places are delayed. And this is tying into a pilot that we're currently working on, freight signal priority. So if you know about the bus booster technology that AT is adopting, that is a very similar sort of thing. It's actually already in existence on Tamaki Drive down near the port. And we have a list of a handful of intersections and corridors that we're looking at, incorporating this dwell time data, as well as some the industry identified. And we'll be looking to either provide priority to these freight vehicles to get through camera detection technology or connecting their GPS systems. Finally, this is the last one, sorry. How is this all relevant? We bought this set of data for Auckland, but it's not an Auckland-only issue. Freight movement doesn't end at the city borders. It has national implications, and it's important for a region's economy. Freight is not just one truck on a road, and it's important to understand the full complexity. And some of the lessons that we had learned through this whole thing was collaborate with the freight industry. They have their own data, they have knowledge, and it is very accurate. We found through our network review that most of the freight network was actually fit for purpose. We had very, very few minor changes to be made. And finally, just to take things away, freight needs to be balanced with other modes, but it still is needed in cities. So the quote I always like to give is, the best time for planning freight was 30 years ago, second best time is today. Thank you.
Thank you very much. If you have any questions for Adam, please come back for what was the last session, when we're now going to be having a Q&A. And I'm very glad to welcome Manoj Dolly from Elements to the stage. Thank you.
Thank you. Yeah, good morning. Well, thanks to ITS, I'm presenting the same topic, but with slightly different twist from last year. Just as a quick introduction about myself, I'm actually an e-ruck provider in my day job. Elements is a bootstrapped startup, which I started about 3 years ago, and we were co-funded with the NZTA Innovation Grant, which led to a project which we delivered to one of my electronic ruck customers, for whom I knew intimately their problems, which was in the traffic safety industry. But today I'm going to just talk about what I understand as physical AI and what's changing now, as well as the use cases that are applicable, also with the project which we delivered, and there's a nice case study on that. So if you in my perspective, if you look at, this terminology, I've just stolen this slide from something that I was reading, where the term was "software is eating the world" was coined by in around 2011, when SaaS was a big thing. All menial tasks were software was coders were writing it to automate, and that's when software was eating the world. But now there's a new term which is being coined as AI is eating the software. So what that means is, obviously, you heard the previous speakers say, including Matt and everyone earlier, coding is now being done by AI agents, right? So AI is eating software in a way. And also, in terms of physical AI, for me, physical AI is when you're looking at combining digital intelligence to real-time outcomes. That's when, in a built environment, it's quite different. In normal LLM models, AI is taking data, interpreting that, and giving you output, or even in an IoT environment, data is going to a cloud server and then being processed. So there is a lag, whereas in physical AI, there's no time for this lag. It's absolutely instantaneous and critical, and that's why autonomous vehicles are an example of physical AI, as well as robotics. So so coming back to the use case which we were trying to solve, the problem that was given to us was in a traffic environment, TMPs, traffic management plan environment, there's vulnerable public and worker safety. And what we found that NZTA's research had said that almost annually there's 10 to 12 fatalities, including traffic workers. Right? The people who are standing there, guiding the traffic, reducing the speed to 60 kilometers an hour or 30 kilometers an hour at certain road intersections or on main national highways where roadworks are being done, and they are highly vulnerable, and how do we protect them, right? So there was a lack of real-time insights for objects, people, and of course I'm extending this now to airports and railways. I'll have a couple of slides on that later. And then, of course, you've seen a number of presentations today and yesterday talking about cameras and AI cameras, how they are used. But in reality, no one's talking about LiDAR. And I wanted to bring that into context, why LiDAR as a 3D sensor is far more effective to solve this problem today, and how LiDAR technology has evolved. So what we aimed to deliver was a hyperlocal solution that will deliver safety to these road workers. So we created a sensor fusion using LiDAR, GPS, some IoT technology, which we were very familiar with being in telematics for the last 15 years, and also created a sensor fusion of collating all this data and looking at the point cloud density and processing the PCD data at the edge and applying machine learning algorithms and analytics to it. So that way we could trigger real-time events and alarms to respond. And how we did that, you will see that in the case study in the video which we have. However, coming back to LiDARs, LiDARs are extensively used in robotics and autonomous vehicles combined with sensors, right? But LiDARs are unique in a way. The cost of LiDARs are coming down. There are at least about 5 major manufacturers. We work with one of the top Israeli tech companies called Innoviz. And now their LiDARs are being used in all the European cars for autonomous vehicles. Like, for example, the BMW i7 uses an Innoviz LiDAR in its grille to actually tell the car for forward collision and looking at the built environment while it's in motion, right? So we believe we are the first movers in the intersection of AI, machine learning, and LiDAR to create a fixed or a portable installation. So we have taken all these components, all these sensors, created a sensor fusion, and provided some machine learning and analytics to actually be able to give it in a usable format to traffic management as well as the traffic industry in ITS. So how we did this, you'll see that, I mean, this is the kind of the screenshot of the Alamance AI, and I'll show you the video, just to explain to you that you can see, this is just in front of our office in Newmarket, where the intersection where the Ferrari showroom is. There's a wee little bus stop there, you can see, and Epsom Girls is just across those trees. That's the grounds of eggs. So we placed the LiDAR on top of a ute just in our car park on the left here, and that had a range of almost 100 to 150 meters. And a LiDAR is different to cameras because it can measure speed and velocity. So we are able to classify the objects, if it is a car, if it's a pedestrian, if it is a two-wheeler, and actually classify those objects, identify them at what speed they are coming in. And there's an intersection here, which is a Broadway intersection to Broadway and Alpers Ave and the St. Mark's Road. So that's where the cars come and slow down. So assuming if there is a traffic works program happening on the street, then you can actually create these virtual geofences. So one lane is the incoming traffic, the other lane is outgoing traffic. And if you have another lane where you want to reduce the speed because there's a traffic management plan being implemented, you can do so and actually enable and actually monitor what's happening there. So at the moment in New Zealand, when you look at temporary traffic sites, there's no real-time data. It's extremely difficult to get those analytics. You know, there are tons of technology at the intersections and likes of that, but in a temporary location, there is no such technology that can be rolled in. So you can see here, just a snapshot, we had created 2 zones. On the top left, you'll see the zones. On the right-hand side, you have the business rules, whether you want to, create a role, what is the area of the zone, and you can select the type of objects you want to classify, cars, vehicles, two-wheelers, including humans. And LiDAR can work in any kind of weather. Doesn't require light as much as a camera does, be it, storm, rain, day or night. LiDAR can be working 24/7. The other interesting thing about LiDARs is you need just a single LiDAR to cover a large area compared to cameras where you may have to mount multiple cameras. Right? So just, and you can see the vehicle count there, a snapshot, about 10,855, 364 trucks passed through at that point in time, and about 112 pedestrians. So doing the traffic count becomes extremely easy. So let me just try and play this video.
Code 5, we got vehicles coming towards us.
It is a high-risk job.
We've got to deal with people doing crazy things on the road, people driving fast.
I worry about it every day. We're not coming home till this one.
If only there was a way to predict accidents before they happen, to constantly monitor the site in every direction, to keep our staff and crew safe.
We've got the Guardian looking after us. It uses LiDAR, which is like radar, but with lasers.
Not the pew-pew type, baby. Nice day for a ride, eh?
LiDAR is a 3D camera. So it's protecting privacy, not filming you as a person. It can see in all kinds of conditions. So it's super accurate and it can see the bigger picture around a site. It's AI superpowered, so it can kind of see around corners and predicts accidents before they happen. It allows us to make adjustments using predictive analytics. When there's a speeding vehicle approaching, the Guardian will let us know instantly on our radios.
High speed ingress.
It's great to know that it's got our back. It will do risk assessments and tell us if we need to modify our site, even let the team know back at the office. It's helping us and our crews make the right decision on site using real-time information.
Beyond being our guardian on site, there's a range of other uses we can achieve with this kit. Things like speed surveys or traffic density monitoring. It's really enhancing traffic management and ensuring safety.
And us kids know our mums and dads are coming home safe.
So that was the project which was co-funded by NZTA about 3 years ago, which we did the prototype. And we have that temporary kit, which we are now migrating to a permanent kit that can be mounted on top of utes and vehicles and be able to be driven around doing the monitoring. So just to go quickly through other use cases, traffic analytics, as I explained, you can do real-time vehicle counting for precise traffic monitoring, congestion monitoring. And again, you can define what objects you want to classify and train the model to actually determine the object classification. And also, if you have any objects lying on motorways or highways and you want to remove them, you can do object tracking and instantly inform someone to take action. Same thing with airports, define restricted zones inside the airports to alert unauthorized individuals and also analyze passenger movement to optimize operations. Again, you can understand the use cases are plenty. Same with railways. You can actually create virtual geofences and alert if somebody's really crossing a certain imaginary line or a yellow line very close to the carriages when they come in. So that's hazardous zone identification. Excess cargoes and freight trains, overhangs, crowd analysis during rugby games or whatever. You can mount a few LiDARs in Eden Park and instantly monitor how many people are there. So there's real-time cloud monitoring. So the data analytics is on the edge. And also there is a management platform, because if you have multiple such temporary or fixed installations, you can manage all of that in a central platform. So that's the end of the presentation. And really just to give you an idea, the technology that's been developing now with LiDAR, especially with Innovis, they're putting in more AI at the edge. So that means at the sensor level itself, they're computing that. They're putting higher compute at the sensor edge. So you don't have to take it to a cloud. And that's a new advancement that's coming in, and it's really going to be interesting. Thank you.
Thank you very much. I found that particularly fascinating use of LiDAR. That's great there, and seeing the wide range of uses that can go to. I'd like to introduce Howard Wang and Johnny Chen from Auckland Transport, who are going to talk to us about integrating computer vision with traffic infrastructure to optimize network performance and improve road safety. Welcome to the stage. Thank you.
Thank you, Liz. So it's very exciting today that we're going to present our work in the past year, integrating computer vision with traffic infrastructure to optimize our network performance, improve road safety. And so we are from a team of about 20-ish computer vision developers. And we've been working on using computer vision technologies to improve our transport system. So I'm Johnny Chen. I'm leading a team of computer vision engineers. And this is my colleague, Howard. He's leading another team of computer vision analysts. So yeah, let's get it done. Oh, sorry. Yeah, so first, our purpose. AT cares about for all those who use transport in Auckland. And we do this by supporting people and delivering a transport system that helps Auckland grow and remain sustainable. So more about us. Auckland Transport itself is a council-controlled organization responsible for delivering and managing Auckland's transport systems, which includes roads, public transport, and future transport planning, focusing on keeping the network safe, efficient, and fit for purpose for this growing Auckland city. And our team, computer vision team, we've been here for roughly, I think almost a decade. And we start with as a small team with few developers, and now we are running a 20-ish developers team. So our purpose is to design and deliver data-driven solutions using camera or video analytics, which turns video into insights to support operations, enforcement, safety, and planning across the network. Our work ranges from real-time monitoring and scalable analytics, more about end-to-end integration of systems that help teams to make faster, better decisions. So there are 4 themes that we have brought to Auckland Transport with computer vision technologies. We have enforcement, we have traffic monitoring, incident detection, we have network performance and optimization. Last but not least, we have safety and asset protection. So today, in our talk, our presentation, we're going to cover 3 of use cases we have selected from the work we have done in the past year. So I will hand over to Howard, my colleague, to start with the first use case. Howard.
Thanks, Johnny. So today we're going to introduce 3 scenarios to how we use computer vision to optimize traffic performance and improve safety for local users. So the first one, so safety driving, domain road cyclist and motorcyclist safety improvement. So in Auckland, you may realize that vulnerable users face a major safety, especially at intersections. About 48 deaths and injuries in both pedestrians, cyclists, and motorcyclists, also maybe scooters. About 43 of those crashes happened at intersections. So you can see from the left chart, from 2019 to 2023, for 5 years, we recorded 200 cyclist DSI or 18 across 18 network. About half of them crashed at intersections. Also 667 motorcyclists DSI across 18 network, and more than 250 DSI. So to address this, we developed a proactive solution to improve the cyclist and motorcycle safety. We chose a domain road intersection as a rollout place. So in the solution, we installed a front camera, actually thermal camera in the entry point for the cyclist and motorcyclist. And also in the intersection point, we installed a VMS signage which is visible for the road turning vehicle. And the front camera can detect object types and the speed and trigger alert to the control layer, which was developed by our team. So the control layer, we actually, in short, we just call it messenger. The messenger will calculate the travel time from the entry point to the intersection and trigger on the VMS. So the driver can easily observe the VMS is on, is flashing or something, and waiting until the cyclist or motorcyclist pass completely, so the driver can turn right safely. So such a solution, we roll out to 11 intersections since 2023, and from the data from the safety team, we found like it's about 50% crashes reduced. So this is one scenario. This is a video. Maybe I can. How to make a video?
Oh, it's playing.
Yeah. So you can see the whole process of vehicle waiting in the flash media and turn right. So the VM signature is on and motorcycle cycle is coming. So until it passes, yeah, then the vehicle turn right. So yeah, such a solution can avoid like conflict between the cyclist, motorcycle, and the vehicle. Such a solution. So this is scenario 1. Scenario 2, traffic control optimization at BP Fanshawe Street use computer vision analytics to support SCADs to adaptively adjust the traffic signal system. So many of us may have such experience when we press a pedestrian push button. It takes
this sound.
Yeah, like this. So yeah. So yeah, it may take a long time, even no vehicles come in. So similarly, also for the driver, it also takes a long time. No pedestrian, no any pedestrian crossing. So to address this, it's like, yeah, definitely it's a waste of time for both pedestrian and drivers. So yeah, because the whole system is based on Auckland transport, like Auckland traffic signal control system is primarily based on SCAD system, SCAD Sydney Coordinated Adaptive Traffic System. Maybe some guys, so first time to know this name. But SCAD is good in like to detect the loop, to get the loop detection as an input, but it's limited of visibility of like key traffic dynamic information such as queue, movement, and incident. So computer vision is a good like it's kind of like a complement, like provide continuous high accurate detection for vehicle and pedestrian, can deliver like richer and more reliable data. And also the computer vision detection can be, the output can be structured as inputs to feed into the signal control like a PLC. So we choose Fanshawe Street near BP gas station as a performance pilot test. So we, because we have two approaches, two directions, eastbound and westbound. So top two is cover westbound, and the bottom two cover the eastbound. So we designed two zones, just cover both directions. We use our own computer vision tool to detect pedestrian and vehicles present on the ROI we predefined. And once a pedestrian or vehicle detected, alerts will be triggered to our control layer or messenger. You can see here. So this is a whole, yeah. So here is like a, so this is like a backend like computer vision analytics pipeline running the environment in OpenShift, and the trigger alerts through the messenger. So messenger is very was designed highly scalable and can support multiple zones. But currently we just support 2 zones on BP Fanshawe. Yeah. So the alerts trigger to messenger do like some logic in the backend, like a fuse alerts and the trigger to the PLC to control SCADs. So SCADs will do some like adjustment. So for example, like cancel pedestrian phase or cancel vehicle phase. So we so this project in performance pilot testing stage at the moment. We do some like real-time performance testing. So this is scenario 2. So yeah, let me hand over to Johnny to cover scenario 3.
Yes, hi. So the last but not the least scenario I'd like to showcase today is about how we do operational alignment on Merrill Street. So there's a bus lane there. There's a map of the design of our bus lane. And as you can see on the top, there's the bus lane, and on each side of the street, we have 3 lanes. One of those would be the bus lane, which is doing CCTV monitor enforcement from 6 to 10 a.m. weekdays. So the use case here in some scenario when there's something happen, when there's traffic, for example, or incidents, we like to temporarily switch this bus lane to general lane. So general cars, we can use it without being enforced. In that case, we need to indicate people that it's okay to use the lane, it's not bus lane. So we have the signs installed there. You can see when it's green, that means that it's good to go, you can use it. When it switched to a different mode, you will see it says it's a bus lane that will be visualized, I believe. Next slide. Here. So it has two modes here. When it's doing bus lane, when it's acting as a bus lane, we have this sign showing it's a bus lane there. When it's being used as a general lane, it becomes a general lane. People see this sign, it's safe to use it, it won't be monitored, it won't get a ticket. So how to do that? We have operators sitting at talk, and once we have some situation happening actually, then we need to initiate a lane switch command, and that will be sent to our field PLC that trigger this sign switch and turns this bus lane into this green arrow. And at the same time, we also send a signal to our CCTV monitored special vehicle lanes enforcement system to tell it it's okay for people to use the bus lane now, don't have to monitor it. So in that case, these two operations will be aligned automatically. So yeah, I guess that's the last but not the least use cases we like to demonstrate today. So that's what we have done the past few years. In the future, we are looking forward to working on more use cases. For example, we like to do some automated actions when there's an incident detected on our CCTVs. We like to just show something to alert road users. And we like to use CCTV to optimize our network, our transportation as well. With queue detection, when we see there's a long queue, we don't need to initiate something. We need to take some actions. And we like to try our dynamic lane management on more corridors in Auckland. More adaptive signal control with gaze integration, and provide more informative journey with some information that we can detect it, or we can be picked up by different systems. So it's all about integration of our computer vision technologies, third-party systems with our public transport. Thank you.
Thank you very much there. Questions will come in through Slido for the Q&A panel, which is replacing the last session. So if you could join for that, that would be great.
Okay.
Thank you very much for a really interesting presentation.
Thank you.
I'd now like to welcome to the stage Johnson Yang from the Resolve Group, who is talking about predicting the severity of run-off road crashes. Thank you very much.
Hello, everyone. So my name is Johnson Yang. So at the moment, I am pursuing a PhD at Transport Research Center, and also working as a senior consultant for Resolve Group. I've gained a Master of Transportation Engineering from the University of Auckland and a Master of Applied Computing from Lincoln University. And this was actually my research piece of work done back in Lincoln in 2023. Oop. Oh, yeah. Okay, so just a bit of background. So why we need to look at the run-off road crashes. So this research was done in 2005 by New Zealand Transport Agency. So the run-off road crashes, it was about 50%, half of the New Zealand rural fatal serious crashes. But I assume this number has gone up so far, so probably a bit more. And if we look at the nature of the crash, so the crash is a very complex event, right? So it's a multifactorial, and there are a number of factors that are contributing to the crash itself and those factors that are non-linear. It was driven by interactions, and it's not just a single cause of this event. So there were some traditional statistical models. For example, logistic regressions. It was kind of traditional methods for studying those crashes. I'm not saying it's not performing well, but for those models, we have to sort of preset the functional forms and interaction forms. And when you're dealing with high-dimensional data, it has some drawbacks. So that's why. So I have, looking at other potential approach. So machine learning coming to my mind. So what machine learning can solve is it got advantages in capturing, interactions. For example, the tree-based models. What we will introduce. What we introduce today. There will be 5 tree-based models. So you can learn those non-linear effects without pre-specifying those interactions. And it has a better performance in dealing with high dimensional data, especially those categorical and numerical variables. And combined with the sharp analysis, which I will go through next, you can explain and visualize those interactions. So I have got the crash data in the last 5 years. That's from the 2018 to 2023. So you can see that the temporal and spatial distributions. So you can see it distributes by the year, the day of the week, and the month, and also the hours of the day. And that's the spatial distribution in New Zealand. So you can see the majority of crash actually occur in those population centers like Auckland, Wellington, and Christchurch, and those transport corridor. Yeah, so this was a summary of the case data. So we only focus on the run-of-road crashes. So there's about 69,000 crash record, the run-of-road crash record. 8.2% were severe. So I define severe as those fatal or serious injury crashes. And there are 685 were fatal crashes. So that you can see the one obvious observation is the data imbalance. So the non-injury it's almost like 70%, and then fatal is just 1%. So these are just some records. So it has the crash ID, severity. So it's just a sample for you to visualize. And so I only look into those road and environmental predictors. So I didn't look into human factors. Obviously, that contribute a lot. For example, alcohol and drugs. So I only focus on those road and environmental predictors in this study. So this is the overall workflow design. So it's called prediction, comparison, and explanation. So the first step is to define what does it mean by severe and what does it mean by non-severe. So I have converted from a multi-class classification to a binary classification for the purpose that we focus on the DSI, which is a death and serious injury, and also it's just for the simplification of the studies. So we don't want to, we just save time looking at each 4 category. For the model development, so I split the train and test data. So 80% are train data, and the 20% is the test data. And then for the issue of data imbalance, I use class weighting. And then the threshold turning is just to optimize those thresholds, the classification threshold. So the model going through iteration, and then it defines the optimized threshold for classification. And then there are different models. There are model matrix or performance matrix that I have used. For example, accuracy, precision, F1, recall, and confusion matrix. And then finally, I use sharply addition explanation. It's called sharp analysis to sort of visualize those feature importance, those contributing factors to crashes, and then identify their relationship of interactions using the local sharp analysis. That's why I call it feature dependency. So these are the 5 models I've been using. So the decision tree is just a single tree model. So it's the baseline model I used. And then random forest is called bagging models. So they're looking at different trees. And then SGBoost, LightGBN, and CapBoost, they are boosting models. So it's these 3, they are going through a iteration to self-correcting while learning. So here are the model performance. So when we look at the DSI, obviously we are more interested to understand, the recall, severe recall. So it's the how many positive predictions over or among all the observation. So so you can see, so the bottom left is the false negative. So it's predict. So the actual crash is a severe, but it's predict as non-severe, which is very significant because that means the model missed some severe crashes. And the top right is the false alarm, right? So it's actually a non-severe crashes, but the model predict as a severe crashes. So overall, LightGBN got the highest accuracy and F1 score. So F1 is a harmonic mean of the precision and recall. And SGBoost actually identified the most number of severe crashes. So SGBoost probably is better in terms of the DSI prediction. Here we go. We got a list of the factors that are contributing to the crashes, the severity of that run-of-road crashes. So the top one, the positive speed limit, and then primary surface condition, so that's wet or dry surface. And the third one is the weather, so it's a fine or bad weather. And so that's just an overall picture that's to visualize and explain the model itself. So this comes from the best overall model, which is the LightGBN. And the graphs to my right, so these are the local analysis. They look at the different category of road. You might see the words a little bit smaller, but so for urban roads, the overall trend is that it's less severe. So you can see it's blue and it's negative. But for those positive, you can see the major rural to minor rural. So those actually contribute to high severity. But interestingly, for those motorway crashes, it's actually contribute negatively to the severity. And here is just a comparison between the alignment of the road. For example, curve contribute a lot more. I would say positively. Straight is actually reduce the severity. In this case, it's in the negative direction. So this sort of analysis it's actually provide the evidence-based approach. So looking at the general trend of this crashes. However, there are still some limitations with these studies. So I only look at the 5 years crash data, and I only use New Zealand data. So there are some limitations of generalize these studies into other countries, probably outside New Zealand, and obviously I exclude human factors. That's aligned with the safe system approach. They're only looking at the environmental and roading factors. And obviously, the case data itself is very raw data, so that records by New Zealand Police. So some of these are incomplete and inconsistent. And also, there are some factors, for example, for curvatures. So it's a lot of details that hasn't been captured and it hasn't been quantified. So the conclusion is that the explainable machine learning with sharp analysis really adds some values to the evidence-based studies. So it proves that you can actually analyze the large and high-dimension data, and it's particularly sharp actually explain and visualize those factors that contribute the most and their relationship. But there's no a silver bullet. There's no one model, right, to solve all the issues or to understand everything. So we need to be aware of the trade-off. And we have to acknowledge that this study, it has some limitations. It's only for sort of the patterns analysis or risk screening. So it's not a study of the single crash. So it's just an overall trend analysis. And thank you very much.
Thank you very much. If you're sending questions through Slido, please at the start of the question, if you want it to go to a specific person, please highlight that within your questions. Thank you very much. Please welcome Andrew Gurr from Fusion Networks, and we're looking forward to his presentation. Thank you very much.
Me too. Is that working? Very good. Hello, yes, Andrew Gurr, CEO of Fusion Networks. I am a non-technical owner of a technology business, and I'm here to provide you with my perspective of the impact of AI in a very recent period for me, which is this year. I'm using a interesting analogy, which is for a transport conference, which is the event horizon, which I believe I've traveled through. So this is a personal experience. Very scary on the way in, and totally uncertain where you're going to get to the other side, but I'm hoping that my journey could be of use to some of you. Why? I think in my short career, this year is the greatest change I've gone through in terms of how I operate on a day-to-day basis. And so I'm here to share that experience with you. A little warning, this presentation is more philosophical than technical, so engineers can go about emails. I've got a few little things, hopefully will keep you excited. And a disclaimer that both ChatGPT and Claude were suspicious about my visual use and the intellectual property they may have passed, but we're going to look through that. To start, we're going to do we need a little context, excuse the pun. So we're going to do a small survey in terms of the use of AI with everybody in the room. No idea how this is going to go. So I'd like everybody that's using AI on an almost daily basis to stand up, please. Yeah. Well, expected that. That's good. So sit down, or stay standing, sorry, if you're using AI tools to build anything that kind of operates. I'm not going to get any more explicit than that. If you are doing it, you'll know it. Very good. Okay, stay standing if you're using AI code to build those tools. Yep, everybody still stood. Okay, stay standing if that code creation is in the wild. It's no longer living and operating on your laptop. Okay, we're down to one. And stay standing if you are not an engineer by trade or training. Congratulations. All right, I'm not the only one in the room. We've gone from everybody to one person. So we're going to go through my journey and kind of see what that looks like. And the clicker. I have no idea this is going to take me 15 minutes. Ooh. Okay. You're welcome to write those numbers down. I don't know if they're really big or really small, but Claude says they are. This is the number of tokens and lines of code I have written in the last 3 months, which is really unusual because I'm not an engineer. I've never written code before. So we're going to go through the how, because in my view, in our business, I would like everyone that works for Fusion to be doing this in a year's time. And the collective output of that is interesting to wonder what might happen. So where we're at is this phase which is called luminal. I was told this by a philosopher. It's called in between. So we're in between what we used to do and what we're going to do. And the question is what it's going to look like. I'll have a little perspective on that, but the point being is that we need to start unlearning what we're doing today, and the only way to do that is to stop what you're doing the way you're doing it today, and try doing it a different way. And that's kind of how you approach the horizon. So I'll take you on a little bit of a journey, my journey. Ooh, we'll go. So there's a little example over the last 3 months, if you can read it, of the things that I've pointed my attention at to try and do it differently than I was doing it before. We went past the 1 million. Little scary number. So that's the predicted increase in capability of AI tools in the next 3 years from where we are today, which is compounding the capability of the tools, the investment that's going on, the underlying speed of everything, multiply it by today's capability, that's possibly the increase that's going to happen. So it's worth giving this a go. Right. That's right. So a technology company like Fusion recently did a hackathon, and they did the hackathon in teams of people that were represented here. Those teams of people were given the same problem and asked to come up with a solution using AI. The question is, can you guess which team won? And I'll tell you the answer, because you won't, and the answer is marketing. And the question is why, and this is why it's so pertinent to everybody in the room who's not an engineer, that is not currently doing weird and strange things with code. And that is, I believe, the power of AI is the intersection between these two things. So if you have a creative mind, and you don't mind breaking things, I'm going to explain my ability to break things in a minute, and you have context or you have domain knowledge about something specific for you, and you apply those two things with some curiosity using AI, you will achieve some interesting things that you didn't think were possible, and possibly get in trouble. So, speaking of getting in trouble, this is the point at which I believe I transitioned from my old way of working through the event horizon into a new way of working. And I'll explain the story behind this while you read those 3 little lines. You can read them, I can read them out if necessary. So I had been trying to build a spreadsheet of kinds that was accessible only to my executive team, which was a little more interesting than an Excel spreadsheet, but I wanted the data to live somewhere where it was safe. So I built an interesting Excel tool using some Claude help. It moved on to a HTML file, but that wasn't really kind of enough. I needed it to go further. So I asked Claude to help me build what I'd asked it for, and it came up with 3 options, and this is the architecture that it proposed for those 3 options. So I don't know how technical you are, but if anybody can tell me which is the least risky one, I'd be happy to know. But either way, I closed one eye and I started at the top and got Claude to start building them. The thing is, it kept asking me really interesting questions that I didn't know the answer to about letting it do things that I didn't think were very sensible. Well, I didn't really know. And I finally got to the last one and decided I needed to try something. So I went all in on number 3. And it proceeded to build an app that ran locally on my laptop And like a proud father, my first AI app was built, but it only, even though it was beautiful and did what I wanted, it only ran locally. It really wasn't solving the problem. So I took it into the office the next day and subsequently had my laptop removed from me. My security team wiped my laptop and handed it back to me with far more security controls, which would prevent me from doing exactly what I had just done previously. So sadly, my app no longer ran on my device, but what did happen was they took that, they cleaned it up, they put security controls in it, and they published it into the cloud, which was exactly what I wanted. I just didn't realize that that was possible. And there it still lives to this day happily doing what it was told to do. They went one step further, which is they gave me a template. And they said, next time you want to do that, use this. And I've been using that ever since to build things. Now, as a technology business, I've got access to that capability that a lot of people don't have. But essentially, in my view, that took me through from one side of the black hole, where I didn't really know what I was doing, but I was very curious, to the other side, where I had some help and the right guidance to do things, but I could still continue to be as curious as I wanted to without breaking my machine. This is a little bit more boring, but essentially out the other side, this is what we've done to try and, I guess, take the rest of our business on as rapid a journey as I've gone through. We've got a policy, we're training people, we've got controls on machines, we've got a bunch of AI champions, we're up to about 6. We've got over 40 engineers trained up and starting to work in the same way and trying to encourage them to be as curious as possible, because if you're not encouraging people to be curious, you're never going to create anything. And fundamentally, we've worked out that there's a difference between prototyping and production. And if you can encourage people that have domain knowledge to be as curious as possible and creative, they will create things that you could not do yourself. You just need them to be supported with the ability to put things in production if you want them to be useful for the business. So like Matt was talking about, that whole teaming thing. So essentially, a team of people got my app where it needed to be, and essentially it was still my creativity that got it there. So here, I was just going to show this. So my brain's worked quite differently since I've worked out and realized and had these capabilities. So this just shows the variation over the last 3 months of things I've been working on. Some of that is I've had different things to do, but some of it is now that I've broken through, I've started playing with different things that I otherwise wouldn't. So just a little show and tell. And here's an app I built on Monday. So this is a little AI questionnaire, so about your maturity. I've used somebody else's by approval. So I built this on Monday and I launched it at my dev team at 2 o'clock and said, could you please make this work and live? And so Monday afternoon it was up, so this lives in the wild. And essentially you can go and check your own maturity from a business point of view. And at the end, if you want some help, you can click yes and it'll send it to me. And that's me. Thank you very much.
Thank you. Stay up here. Sure. Speakers from the session this morning up. We can have an opportunity for some Q&A. If you haven't sent through any questions yet, and you've got some, please send them through. Take the microphone with you and we'll pass it around. Another one? And we have a second microphone as well. Thank you. Yes, please take a seat. Thank you. So I'm going to go through the Slido questions and make sure that everybody has a question, so some might come from me as well. I'm going to start off with Manoj. They have us a question about here, is LiDAR gazetted for speed detection in New Zealand?
I don't believe so, because I think they use radars. But when we did the project and the prototype, there was curiosity from NZTA to use it for infringement, potentially. So you can do it by sensor fusion by putting an ANPR camera to the LiDAR and actually, detect the number plate. But that wasn't in the scope at that stage, but there is possibility, technically.
Yeah, and while you've still got the microphone there, what was the cost for procurement and maintenance of LiDAR compared to cameras? And is it worth the extra accuracy we may have?
Yes, in the way, LiDARs are, of course, at least 7 to 10 times more expensive than AI cameras. However, they can give you longer range, and if you want high fidelity point cloud density of a real-time infrastructure, LiDAR is the way to go because it'll work day and night in any kind of weather conditions. Whereas with cameras, you might need multiple cameras. Today, LiDARs can go up to 1 kilometer.
Yeah. And another question, for road construction protection using LiDAR, will insurance accept what's been seen given that there's no video evidence?
To be honest, I don't know.
You don't know. Okay. Thank you very much. Adam, a question for you. I think it's largely been covered off by later on in your talk, but does freight count data set cover all the routes within the Auckland area, and how do you collect those?
So AT already has our regular traffic count data that counts general traffic, and then it has a percentage heavy commercial vehicle, and that's what we use to check things. Those are all over the place. But obviously, as the road network expands, new count loops and tubes need to be added to those new roads. So some of those aren't covered yet. As far as our E-road package that we had purchased, that was for 23 and 24. So it covers all the roads that the trucks traveled on in those years. It's not limited to just the strategic freight network. It covers all those roads. And in fact, when we were looking at candidate corridors to add to the freight network, we found some that had high volumes of trucks where when we looked at it on a closer level, it's, oh, this is very clearly a rat run. We don't want to add this to the freight network at all. And so the E-road data covers a lot more of those roads. We can then supplement it with the AT count data. And as we purchase newer and newer sets of data for every year, it'll presumably cover more and more of these new roads that are being added to the network.
Thank you. And I've actually got a question from me as well. As we see increasing electrification of freight vehicles, road freight vehicles, do you anticipate some routes might change? For example, drivers use their lunch break, their mandatory 30-minute break to charge somewhere where they would not have previously dwelt. Have you considered the effect of electrification that might happen on routes?
So yes, and we have very, very regular meetings with the freight industry, and they are updating us on the progress of electric trucks. Obviously, a lot of truck drivers, like many of us, are creatures of habit, and so a lot of their routes will stay the same. But as far as where the chargers are, they will obviously be going to where those are. And that's something that I know the Ministry of Transportation is also looking into, and NZTA is specifically having these chargers for trucks in appropriate spots. So they wouldn't put it at a BP that's, in a residential zone. They would put it at a place that's already kind of a place where trucks refuel, just to kind of keep with the current network and, just have them in logical spots. So it is something that as it develops, it is something where we take a look at it every year, and we can provide updates every year to the network. And so if those start to come in, they'll be examined periodically and can be added.
Thank you. I've got a question for the AT team at the end there. What were the biggest challenges in integrating SCAT's traffic controllers into your solution?
Yeah, so biggest challenge actually is like the real-time performance, I think. Because so the SCADs need to react or adjust the traffic faces immediately according to the traffic situations. So the computer vision may have some challenges, and for example, the network transmission, the the AI model inference, which will take some time. So we have to optimize each modules, like we call like upstream modules. For example, we output the detection events every 100 milliseconds, and trigger do like fusion locally, and yeah, the events can be fused immediately, maybe just a millisecond level. So the whole end-to-end, we hope to control like within 1 second, like the scarce reaction time. So that's very challenging. Unlike other video analytics, maybe not there like a highly requirements in real-time performance, like enforcement, like we can do post-processing, but this one we have to do super real-time processing. So I guess this is the biggest challenge, I think, in the integration.
Thank you. Question for Andrew. The question reads, your slides were excellent. Could you please provide some examples to discuss the application value of AI in your field? It seems difficult for us to know what application you are introducing based on the AI-generated PowerPoint that you used.
Yeah, well, if you've taken a photo of the QR, just put that in the notes and send it to me, and we'll set up a session. It was 15 minutes. It was a bit hard. I decided to go philosophical rather than specific, but I've got about 70 that I've built. If I'm a little more specific, the dashboarding is just phenomenal. So if you've got multiple data sources and information and multiple Excels and you're trying to make heads or tail out of it, then Claude's code creation of dashboards is life-changing. If you wanted a specific example, ask it to do HTML dashboards and you'll never go back to Excel. Use Excel, but build dashboards.
Thank you very much. I've got a question for Johnson. In the data that you presented, there was a definite uplift in crashes at the weekend, particularly Saturday. What's behind that?
I guess it really depends on the travel behavior. People actually, going out, during the weekends, and the increasing movements that potentially contribute to, that sort of number of crashes. And also, if you look at the fluctuation over Christmas and January, that's actually the highest. I think highest around that time. That's because that contributed to the movement of people, that increasing traffic volume. Actually, that's a linear relationship between the volume, the traffic volume, as well as number of crashes.
Thank you. I've got a question here, not quite sure who it's for, but I'm guessing the AT team, but please, if someone else can add to it, please do so. And I'm kind of referring to them, to the team there, because I know you're part of it, but they've got the T-shirts on. So the question is, the radar and camera technology teams sat down together. So from the perspective of cost, deployment, and effectiveness, which do you think has the advantage?
I guess, okay, I'll take this one. I guess it depends. It really depends on the use cases. For speed detection, we have tried CCTV, we've tried using radar. For vehicle classifications, we also try to use the visual way and also try to use data from radar itself. And we found that with visuals, we got a higher accuracy vehicle classification to identify the types of vehicles traveling through a corridor. But in terms of speed detection, we believe that radar is achieving best accuracy at the moment.
Thank you. And whilst you've got the mic there, how can detection results of cameras be effectively and quickly transmitted to pedestrians or drivers?
That's that's a big question. So I guess it's about speed as well, efficiency of the transmission. So we do have some limitations and some in our infrastructure that we don't have enough bandwidth to stream our video data to our data center to process, and we don't have enough time to send it back to the cloud. So we are also trying some edge functionalities that we have the computing all the things done, most of the things done on the edge devices, so we can just send very concise messages to our infrastructure, and which again is integrated with other parties, other components of our system, which can be sitting in the cloud, can be in our on-premise infrastructure again. Yes, I would say, yeah, there are different approaches, different combinations. We're trying to conquer this scenario.
I'm actually going to, yes, extend that question on to you, Manoj.
Yeah. Can I add to that? Basically, if you saw in the video, what we tried to do was we integrated with the DMR system, which the traffic safety workers use, and gave them nearly in milliseconds or nanoseconds an alert that a speeding object is coming towards that zone, essentially. So that is possible. Yes, the latency becomes if you're sending it back to the cloud, but if you're doing processing at the edge, you could alert a street sign or something like that to the, to motorists.
Yeah.
It just depends on the scenario and the parameters and the environment which you're working with.
Yeah, I thought that signal through the radios out loud was really powerful. What happens to that speeding vehicle that you've detected coming fast and the alert has gone through?
Yeah, there was this project wasn't about infringement.
Yeah.
It was more about getting the data which is lacking for traffic temporary TMP sites, right? Because today they lack that data. And we recognize when we did it in 2 sites, there were infringements when the speed limit was dropped to 30. There were still infringements at around 85 kilometers an hour on a 30K zone. And this report is published. NZTA has it. I could provide a copy if anyone's interested of all the data and the trials that were done.
Yeah. Thank you. I've got a question that's kind of for the whole group of you. You've all got tools designed for very specific purposes. What opportunities to applying the same technologies and data sets to other applications are there? Opportunities for things like ruck enforcement?
Well, I can take this. I'm an existing ruck provider. I think obviously ANPR and camera technology can be used for congestion charging, and that will be used from a tolling perspective. But I mean, we are building some technologies now which are purely very simple, because to me, my vision is to commoditize ruck, right? The cost of compliance shouldn't be as high as it is today. So we're playing with technology like Bluetooth-enabled digital hubdometers, which can communicate to street-side cabinets, right? You install Bluetooth hubdometers on all vehicles, I'm talking heavy vehicles, then you create your own network.
Yeah.
You know exactly where they are at any time they pass through a particular node. You know how many kilometers they've done, and you're just debiting them as you go. It's real-time tolling nationwide.
And weight?
Weight is, again, you saw TCA present. Australia has got the OBM systems. There are approved OBM systems. We have integrated with one of them, but OBM systems are not used in New Zealand, right? So onboard mass systems will give us dynamic data, because ruck here is paid on GVM, unlike in Australia where it is, what's the load. Yeah, so in New Zealand, it's irrelevant, really, weight. Yeah. At the moment, the way ruck is structured.
Do you think it should be relevant, dynamic weight in motion?
Well, we don't have that much line haul like Australia, so it's really simplicity is what the current system really does it well. Yes, it's there are winners and losers, but the base GVM-based ruck is perhaps the best suited for New Zealand.
Thank you. I've got a question on the app here, not quite sure who it's for. If CAS data is historical, how do we more accurately forecast DSI reduction?
I think there's a question for me. So I think the industry is now moving from a crash data to sort of the trajectory kind of proactive safety analysis. So they have, you might have seen other presentation. They have used JOM. They have used safety cameras for detecting the potential conflicts. So there is again, a relationship between a conflict to a crash. So they kind of start using those kind of proactive measures to look into how to convert those conflicts into, the potential crashes. So maybe they're moving. I mean, other, I would say territory authorities. They are like including they have different councils, including organ transport. They are slow. They are like just progressively moving towards that trend, which is great. Yeah, I guess that's yeah. I mean, CAS data is evidence based, but it's more sort of not that proactive as like the conflict approach. So that's part of my actually PhD studies. So they're using the sort of the proactive measures to study the autonomous vehicles, which is an incoming technology. So yeah.
Thank you. And I've actually got a final question that I've got based on Andrew's presentation and also ones that we've heard about more about AI in earlier today. You talked about the importance of training and getting people trained up within your organisations of that. When there's a new technology and stuff, there's often quite a lot of cowboys out there. How do we know to pick a good trainer at this moment, at this point, if you don't have a great big tech team sitting behind you that can provide that yourself?
To be fair, I don't think it matters, right? The most important thing is you're trying. And now I look back at what I was doing 3 months ago and I thought, good Lord, you know, why was I doing things that way? You've just got to get into it and you learn along the way. The advantage of having a bigger group all learning at the same time is you learn off each other. So that teaming from a learning point of view accelerates fast, because even watching videos and going through training sessions, I still don't understand things I'm doing. So I don't think it actually matters, just get into it.
Okay, anyone else have got any comments? Okay, we're going to wrap up for lunch there today. Please remember to take an opportunity to fill out the survey. There's a link to that in the email that all the delegates were sent from Donna this morning. And we will be back in here or next door for whichever session you choose to go to at 1:30 this afternoon. Thank you very much.